So today we're going to be solving and graphing, not equations. We've been doing equations so far. Last week and then earlier this week we did equations. Today what we're doing is we're using what's called inequalities. What are inequalities? Well, these are the 5 inequalities. You guys have probably seen them many times. Greater than, less than, greater than or equal to, less than or equal to, or just plain not equal to. Okay? So greater than means more, right? That means more. If you have greater than something, you have more, right? Less than means the opposite. I have less. Well, what about greater than or equal to? What does that mean? How is that different than greater than? How are these, in other words, how are these guys different? What makes them different? What makes these guys different? Besides the little line down here, I know the little line down here, but why do we need that line down there? What's different about it? Anybody? Yeah, Bruno?
The one with the line down there means it might be equal to the
I have another option, right? Here I only have one option. It has to be bigger. Can't be the same. Here it could be bigger or the same. Here, one option less. Here, I have 2 options. It could be the same or it could be smaller. That's the difference, okay? Not equal to, one option. Anything but. Anything but. Okay? All right, so golden rule. The golden rule. So if you look at the steps on the board, which I'm going to put on the notes, I took a picture of it, so I'm just going to put the picture right there, which you guys wrote down. They sound the same. Distribute. Combine like terms on the same side. Use inverse operations to get variables on one side, numbers on the other. Then graph. Number 4, the golden rule. That's really the only thing that's changing, and that's really the only thing. Okay, this idea of the golden rule. The golden rule of inequalities is this. If you multiply or divide both sides by a negative number, you must flip the symbol. Flip the symbol. I'll let you guys write that down. And then I'll talk about what that means. If you multiply or divide both sides by a negative number, you must flip the symbol. Okay? Well, both sides of the blue line, right? That's the first thing. The both sides of the blue line. That's what I mean by both sides, right? When we draw the line down the middle, both sides. Flip the symbol. What symbol? These symbols here. These symbols here. You must flip it. That's the only thing that's changing from what we've been doing. Okay, so a lot of what we do is like, oh, I know how to do that. I know how to do that. I know how to do that. Okay. The steps are on the board. Like I said, on the notes, I'll put the steps up there, but for right now, you guys wrote them down. They're in your notes. So let's look at number 1. It's on the inside, or turn it over, or, okay. Jacqueline, put the phone away, please. That's your warning. Next time I'm taking points away from the test. So please put the phones away. Okay. All right. If I were to do this, don't do this. Don't do this. Just watch what I do. If I were to do this, you guys would know what to do because we've done it many times in this class and before this class, right? Well, essentially, we're going to do the same thing. Blue line, right? Blue line, first of all. Distribute. We don't need to distribute on here. Skip that step. Combine like terms. Are there any like terms on the same side of the blue line? Nope. Nope. So inverse operations to get the variables on the left, or get variables on one side, numbers on a different side. So what I'm going to do is I want to get the variables on the left side. I'll tell you why at the end, but I want to get the variables on the left side. So what I'm going to do is I'm going to subtract 1x over here. This is 1x, right? I'm going to subtract 1x from both sides. Could you add 3 to both sides? Yeah, you could. It wouldn't be wrong, but I'll tell you why I'm not going to do that in a second once we're done. So this goes away. I have 5 minus 4x is less than or equal to positive 13, right? So the x's are on the left side. Now I get the numbers on the other. Subtract 5 from both sides. Negative 4x is less than or equal to 8, right? So far, I haven't done anything I have never done before. Last step, divide by negative 4. But the golden rule says if I divide both sides by a negative, I have to flip the symbol. So the symbol's no longer going to be facing that way. It's going to be facing a different way. It's going to be facing this way. Because I divided by negative 2, or negative 4. I divided by negative 4. Okay? I divided both sides in yellow there. I divided both sides by negative 4. If that was a positive 4, I didn't need to flip the symbol. But because I divided by both sides by negative 4, I needed to. Okay? Next step, last step, is to graph. So this is how we graph these. Front and center goes the number. The number is negative 2. That's the answer, right? So I put negative 2 front and center. They put tick marks for me on there, so I'll fill it in. So negative 1, 0, 1, negative 3, negative 4, negative 5. Usually I wouldn't put that many on there, but since they already did it for me, I might as well. So now I got to graph it. So now I get this question. That's number 5, on step number 5. Open dot or a closed dot? We've done closed dots. If you looked at your notes in the past, we've always done closed dots, but now we have another option, open dot. So for this guy here, which one do you think it's going to be, an open dot or closed dot? You probably know the answer. Open? Anyone think closed? Okay, so let's go back to what we did last notes, right? This guy we had closed, right? Same thing here. I don't know why I don't have that one. Same thing here. What do all of those have besides the bars? We don't have bars today, right? What symbol do all of those have? Equal. They all have equal, right? So this is the rule. When do you know if it's an open dot or closed dot? If there is equal to at all, it's going to be closed. So does our symbol have an equal? At all? It does, right? It does. It has greater than or equal to. So if we have that, it's going to be closed dot. So in the front, you have 2 symbols, right? 2 symbols that have equal to. One of them looks like this. The other looks like this, right? Those are both going to be closed. If it's not closed, or if it's not equal to, they're what we call open circles. This one too. That one doesn't have an equal sign. It has the opposite, no equal sign. Okay, so if we have an equal sign at all, so that's why you take notes, because you don't have to memorize that. Because I see that mistake a lot on tests. That's why I have you guys take good notes so that on test day you can use your notes and you don't have to memorize it. I said open dot or closed dot. You don't have to memorize it. Okay? Okay, now x, what this says is x is bigger than or the same as -2. So where is x? If x is bigger than or the same, which way is that from the dot? To the right or to the left? Which way are the bigger numbers? To the right. So that's the way we're going to shade. To the right. Okay, we're going to shade to the right. Here's a bonus question. My last class knew. I was surprised. See if you guys know it. How many answers do I have for this problem? Answer or answers do I have for this problem? Yeah, an infinite. Yeah, good. You guys got it too. Because people always see, well, this is my answer right there, right? That's one answer. But that's not right. Why is there an infinite number of answers? Why is there an infinite number of answers? You guys are right. Why infinite? Exactly. Anywhere where that blue sketch goes, it could be. Does it stop at that? No, that's why I highlighted the arrow. That arrow doesn't stop, right? It doesn't stop. So imagine having to list all of those numbers. -2, -1, 0, 1, 2, 3, 4, 5. You'd be here 10 years from now, you'd still be writing down numbers, right? And then that doesn't even include what's in between. What's in between 0 and 1? Fractions, decimals, right? So there's an infinite number of possibilities. That's why we graph it, so we don't have to write all those numbers down. We highlight them. So to show people, those are the answers. So if someone said, is 10 going to be an answer? Is 10 going to be an answer? Yeah, right? Yeah, it could be. Yeah, it will be. Because this guy goes on forever and ever and ever. Is -10 an answer? No, because that's on the left side, right? Okay. All right. All right, so let's look at number 2, example number 2. Okay. So split. So we go through our steps. Distributive property. Nope, don't need it. Combine like terms. We don't have anything that's like on the same side. On the left, I have an x. On the left, I have a -61 and a +6x. Those aren't like terms. And on the right, I just have a -55. Okay, so the x's are already together. Which side are the x's already on? The left side, right? The left side. So let's get the numbers on the other. Add 61 to both sides. Add 61 to both sides. Divide by 6. Do I have to flip the symbol here? No, because I divided by +6. I divided by +6. I don't have to flip the symbol. No worry about that. Okay. When I'm making my own graphs, this is how I make my own graphs. The answer goes front and center. So the answer goes right in the middle. I go one number bigger. So one number bigger than 1 is 2. One number less is 0. And that's where I stop. That's all you have to do. You don't have to keep going. You can if you want, but you don't have to do 3, 4, 5, -1, -2, -3. You don't have to do that. Okay? All right, so at 1 is the answer. Am I going to have an open dot or closed dot? Which symbol is it? Open dot or closed dot? Closed. Okay. Here we go. Which way am I going to shade? So this is how you tell. X is where I shade. So this says is x is less than or equal to 1. Well, if x is less than or equal to 1, where is x? Where is it hiding? Over here, yeah, to the left. It's hiding to the left because it's less than or equal to 1. Somewhere over here. Somewhere to the left. Okay. Okay, so what I want you guys to do right now is do number 3. Try number 3. You're going to get an ugly answer. It's okay. It's not going to be a nice, pretty number like we've gotten. It's going to be a fraction. It's okay. All right, so try that one on your own, and we'll go over it in a few minutes. Okay, so we follow our steps. We distribute. No need. There's no need to distribute. Combine like terms. There's nothing on the same side that's like terms. But we need to get the the b's on one side, numbers on the other. Here's the thing. What side do we get the b's on, and what side do we get the numbers on? It doesn't matter. I always like to say get the variable on the left because it helps you with graphing. But is it wrong if you do? Don't. No. Watch, I'll do it the opposite way. Let's say I get the b's on the right side. Okay, so I'm going to subtract 1b from both sides. If you didn't do it this way, watch, you'll get the same answer. So subtract 1b from both sides. So that means I have to add 4 to both sides. That means I have to divide by 8. And I get b, this symbol. That's my answer. All right. Now I'm going to do it again, but I'm going to do it a different way. I'm going to do it the way some of you probably did and show you get the same answer. So here we go. Let's see. It's an ugly fraction. I told you guys it'd be an ugly fraction. It's an ugly fraction. Okay, so let's say I subtracted 9b from both sides. I get negative 8b plus 5, and then a negative 4 over here. And then I subtract 5 from both sides. Negative 8b is less than negative 9. So instead of the positives I had over here, I have the opposite over here. Okay, so let me divide by negative 8. But I divided by a negative 8. The golden rule says if I divide or multiply by a negative number, I got to flip them. So when I flip them, it's going to be that. Do those both say the same answer? Do those both, they both look different. They both have a B, they both have a 9/8, but they say different things, right? This guy says one thing. This guy says another thing. This guy over here says 9/8. What is 9/8? 9/8 is close to what number? What number is 9/8 very, very close to? Whole number. 1. It's a little bit above 1. It's like 1.1 something, right? So it's pretty much 1. So this is saying 9/8 is smaller than B. Okay, so if 9/8 is smaller than B, then where does B have to be? Bigger, right? And that's what this one says. B is bigger than 9/8. So it's saying the same thing different ways, right? If I say you have more money in your pocket than I do, and then I say I have less money in my pocket than you do, that's saying the same thing. They're just saying it differently, right? So I always tell students to write it like this because it just makes a little more sense. Sometimes when they write like this, it doesn't make sense to them. If it makes sense to you, go for it. It's an answer. It's correct, right? Look at all they did was they switched B. They switched B and they switched 9/8. They switched spaces. And then when they switched spaces, what happened as well? The mouth has to open to the B. So you have to keep the mouth open to the B here too. That's all they did. Okay? So which answer is correct? They're both correct. On delta math, the variable will always be on the left. So if you got this as an answer, you would have to move the variable over to the left because delta math says, nope, I need the variable on the left. So that's why I suggest doing it like this, because it makes it easier. Okay. Okay. So we said 9/8, don't change it to a decimal. Just leave it like this. If you want to, if you're like, I have no idea where 9/8 is, go to your calculator. 9 divided by 8, 1.125. So between what two numbers is it going to be? It's going to be between 2 on the bigger side, 1 on the smaller side. Okay. Open dot, close dot. Open. Which way do I shade? Right or left? Remember, they both say the same thing. The blue and the pink, they both say the same thing. So which way do I shade? Right or left? It's going to be right, yeah. 9/8 is smaller than B. So that means B has to be bigger. B is bigger than 9/8. That's to the right. Okay. All right, we're going to do this problem, and then we'll do one problem, more problem in our notes, and we'll be done for today. I promise. We're going to do more practice tomorrow, but just for today, this is good. All right, we're going to do one problem like this in our notes, and then I have another one just like this that I want you guys to do. Okay, so I put this one on here because this is kind of cranking it up a little bit. We have to use all of our steps on this one. Okay. Distribute. Yep. Got to distribute here, right? I've done that before. No more parentheses. I get to distribute. I'm done distributing. Okay, step 2, combine like terms on the same side. I have like terms that are on the same side, right? Over here, I have a 9n and a positive 6n, which I can add together to make 15n. On the other side, I have a -4 and a -8. I combine those together. I can add those together. They're both negative. So I can add those together and I get -12. Okay. Now I need to get the ends on one side, the numbers on the other. So delta math, like I said, likes ends on the left side. So that's what we're going to do. That's what I'm going to do. So that means I'm going to add 10n to both sides. So 25n. Okay, ends on the left. Numbers on the right. Okay. Last step, divide. Do I have to flip the symbol here? No, I don't. Yeah. Hey, come on in. Yes. Okay, so we don't have to divide. because we divided by, or we don't have to flip the symbol, I should say, because we divided by positive 25. I'll show you what a lot of students do. They see this negative 36. I have to flip the symbol. No, that negative was already there, right? The division here wasn't. So the symbol stays. Letters on the left, numbers on the right, delta math is happy. It's an ugly answer. Well, we've gotten ugly answers before. It goes front and center. Okay, so I'm going to go to my calculator and figure out what kind of decimal it is. I'm not going to write it down. It's going to help me with my 36 divided by 25. Negative 1.44. What two numbers is that between? Whole numbers. There you go, between negative 1 and negative 2. Negative 1's over here, negative 2 is over here. Good. Open dot, close dot. Open. Which way do I shade? Am I looking for less than or greater than? N is smaller than this number. So if n is smaller than that, the way I want to go is that way, smaller. Okay. All right. Okay, so we're going to do one more, then we'll be done. So if you go to your notebooks, page 7, where you're going to tape this in a few minutes, write it out. Write number, this is going to be example number 5. Solve and graph. Okay, I'm going to give you a problem. I want you to solve it and graph it. Try it on your own, then we'll do it together in a few minutes, and then we'll be done. 8m minus 3 times 10m minus 10 less than or equal to 9m plus 1 plus 7. Solve and graph. Okay, so the first thing I'm going to do, if you're still working, go for it. I'm just going to get started here. Distribute, because I need to do distributive property. So we got 8m minus 30m plus 30. Okay. Combine like terms. I have like terms on one side, 8m, negative 30m. I don't have to do the opposite there because they're both on the same side. So I add those together and I get negative 22m. On the other side, I have these two like terms. I don't have to do the opposite since they're both on the same side. So when I add those together, I get positive 8. Okay. Okay, step 2 done. Step 3, I got to get m's on one side, numbers on the other. Hey, come on in. Okay, so m's on one side, numbers on the other. So again, to make it easier, because delta math, the letters are always on the left, let's get the letters on the left. So subtract 9m. It's not wrong if you do it the other way, but it's just making it easier on yourself. So you get negative 31m plus 30 is less than or equal to 8. Minus 30 from both sides. Negative 31m is less than or equal to negative 22. Okay. Divide by negative 31. But when I divide by negative 31, I got to flip the symbol because I divided by a negative. Well, there was already a negative there, so what does that mean it's going to do to our answer? Not only do I have to flip the symbol, but it's going to make our answer positive. No more negatives. Okay. Okay, so now I'm going to graph. 22 over 31 is the star of the show. That goes in the front and center. 22 over 31, as a decimal, that's like 0.7 something. So what two numbers is it between? 0 and 1. Yep. Okay. Open dot or closed dot? Closed. Good. Which way am I going? Is M looking for the bigger than 21, 22 over 31, or smaller? Where is M looking for? M's looking for the numbers that are bigger. So that's to the right. Okay. That's to the right. All right. We're going to do some more practice. We'll do that tomorrow. But for right now, we'll stop right there since those are your notes. Okay. So if you're in the back behind you somewhere, there should be some tape, a roll of tape behind your row. Get that and pass it forward to everyone.